Hello, Math 130 students. We are going to pick up on page 1, section 6.1, roots and radicals. So here we have radical expressions, and with our definitions we have the radicand, which is everything underneath the radical, and we also have the index. So I'm going to be referring to the index a lot because that is going to depend on a lot of different ways we interpret a problem depending on the index. If I have a cube root, that means my index was 3. If I have an even root, that means my index was even. If I have an odd root, then that means I had an odd index, okay? So let's go into simplifying our expressions. So we have the square root of 16. So hopefully you know that 4 times 4 is equal to 16. So I have 4. So now we're going to think about the square root of 36, which is 6 times 6 is 36. So now I have 4 plus 6, and my answer here is going to be 10. Now for number 2, well, what this is saying is that I multiply something 4 times and it's equal to a negative number. Well, that is just not possible. This is not possible, so we are going to say no solution. Or actually, there is a solution, but for now we say it's non-real, so no real solution. In the very last section, we're going to realize there's an answer to this, but it would be imaginary, but we don't know imaginaries right now, okay? And if you're like, wait, yes we can, what about negative 1? Well, if I did negative 1 times negative 1 times negative 1 times negative 1, well, I have 1, 2, 3, 4 negatives would end up becoming a positive 1. But we need this to be a negative 1. Therefore, nothing would have worked to get that negative 1. Therefore, we say no real solution. Now, for number 3, we want to look for some number that's being multiplied 3 times to give me 512. So let's think about this. Well, if I think of all my cube numbers, 1 to the 3 is 1, 2 to the 3 is 8, 3 to the 3 is 27, and if I keep going down the line, well, I know eventually when I get to 8, 8 to the 3rd power gives me that 512. So here my answer is going to be 8. Okay? For number 4, we have to remember our order of operations. So we are going to have to add before we do anything else. So 9 plus 16, when I add those two numbers together, it gives me 25. And the square root of 25 is just equal to a plain old 5, okay? And now for the next example, I have the 3rd root of negative 125, and that is going to give me negative 5. Negative 5 times negative 5 times negative 5 is a negative 125. And for number 6, I can think of this as a negative 1 that's being multiplied by square root 100. So negative 1 that's being multiplied, well, the square root of 100 is 10. So negative 1 times 10 is a negative 10. So my answer there is going to be a negative 10. Now, you really want to pay attention to this, okay? This might drive you kind of mad in the homework, so I really want to make sure that you guys understand this. So depending on whether or not you have an even or an odd root, okay, when n is odd, it's just going to equal to the a. When n is even, it's going to equal to the absolute value, okay? So that's really important. So this tells us that when it's even, I should be thinking about the absolute value. So we want to simplify this as much as possible. So I know that I have and it's the 6th root here, and I have my x to the 18. So my goal, hopefully, is to get it so that the power on the inside will cancel out with this index. So if that's the case, I definitely have my x on the inside. So x to what power times 6 gives me 18? Well, that would be 3. So 3 times 6 is equal to 18. So what's beautiful about that is that this index now cancels out with that power. So I'm left with an x to the third power. So that is going to be really nice. And now we have to be careful. So what did we start with? So at the very start, we begin with an even index. And then at the end, we end with an odd power. So because we end with an odd power, we have to remember that this is really going to equal the absolute value of x to the third power, okay? Because let's say it was -1. -1 times -1 times -1 is very different than 1 times 1 times 1. So if you start with an even and end with an odd, then you need that absolute value, okay? So let's look at number 2. So for number 2, what I like about this is that my index to start off with is already a 7. And inside the radical, the radicand already has a 7. So those can cancel out very nicely. So my answer here is y. So what did we start with? So we started with an odd index, and we end with an odd index. So because I started with that index of 7, then I'm okay of saying that this is just going to equal to y. Looking at my next example, number 3, I have the square root of 25 times z to the 6th power. So here my index is 2, okay? So I can actually rewrite this where I'm going to have, the square root of 25 times z. And here, remember, I want to match it to my index. If my index is 2, then what I want on the inside, well, what times 2 will give me that 6 on the inside? Well, that would be 3. So now I know that that square root will cancel out with that square root. And so the square root of 25 is 5. And I have my z to the 3rd power. And don't forget that you started with an even index. And you ended with an odd power. So remember, if you end with an odd power, you have to remember your absolute value. So let's think about this. What is the absolute value of 5? Well, that's just 5. So 5 goes on the outside, but you still have your z to the 3 on the inside. So 5, absolute value of z to the 3, will be your answer. All right, so let's look at number 4. So I have the square root of 9 times y. And I'm doing this in parentheses because I know that by default, the index is a 2. So if the index is a 2, then I know the power on the y would be 2. So 2 times 2 would give me that 4. So now I know that this is going to cancel. And well, the square root of 9 is 3, and you have your y squared. So here, don't forget, you start with an even index, and you end with an even power. So since you end with an even power, you leave it alone. So you have your 3y squared. It's only when you start with an even index and end with an odd power that you need the absolute value. that if you start with an even index and you end up with an even power, then you're good. You don't need anything. Okay, so that is the end of section 6.1. So hopefully you guys got the gist of having to do the absolute value. If not, please feel free to email me or the Math Success Center or our tutor. Thank you.